Everyone, this video is for section 3.3, graphs of polynomial functions. We're going to be taking a look at question number 25 from the exercises at the end of the section. So the problem that we're going to work with is the function h of x is equal to the square root of 4 minus 5x plus x squared. Our goal is we need to determine the domain of this function. So let's make sure that you have notes in front of you, so a blank sheet of paper or a notebook, possibly a calculator if you need it. And actually what I would encourage you to do, if you feel that you have a good idea of how to approach this problem, feel free to work the problem on your own and really use this as a way of checking your solution and your thoughts. All right, let's get to learning, shall we? So our goal here is we want to note that this expression underneath the radical, in other words, the radicand, we know that it's going to have a certain restriction to it. Specifically that a square root, I can only take a square root if it is equal to 0, if the radicand is 0, or if it is a positive number. If we use a negative number, I mean, your calculator, if you try to do it on your calculator, is just going to say error. But the reason behind it is because it would generate an imaginary number, and imaginary numbers do not appear on your coordinate plane. So I'm going to go ahead and focus my attention on this quadratic. And again, I'm going to rewrite this in descending order, just because I prefer to see it that way. There's no benefit other than that. So I know that this expression, in order for it to give me what I'm looking for with regards to a domain, the number that it would simplify down to when I start plugging values in for my x variable, it has to be greater than or equal to 0. So now what I'm going to go ahead and do is I'm going to try to factor this. So I'm going to break this down. So I'm just going to kind of think out loud, I guess, here. I'm going to take a look at my lead term, and it's pretty straightforward to me that I'm going to take x squared and break it evenly. So x squared will just become x and x within each quantity. Then I'm going to move my attention over to the fact that I have a positive 4, but I have a middle term that is negative. So that's going to tell me that one of these is going to be negative, and one of them, well, actually both of them are going to be negative, sorry. Because when I am foiling, if I were checking my work, I should be getting two negative middle terms, and then when I do a negative times a negative, I'll result with that positive 4. And then my goal here is I want to figure out how can I multiply two factors in order to get a product of 4, but if I were to add them, I would get a negative 5. And the result that I would get would be, well, I should probably use minus 4 and minus 1. If you don't believe me, please go ahead and take a moment to pause the video and actually FOIL this out to make sure that you do arrive back at the original expression that we started with. So now what I can do here is I can just break this down and say, okay, I'm going to do x minus 4 is equal to 0 and x minus 1 is equal to 0 and solve for x. If I do this, I'm going to have x is equal to positive 4, or in other words, I'm going to have an x-intercept at 4, 0. And then if I solve for x over here, I have x is equal to 1, or in other words, an x-intercept of 1, 0. So let's go ahead and take a look at a rough sketch of this. And I really do mean a rough sketch. So I know that I'm going to have an x-intercept at 1 and an x-intercept at 4. So now what I can go ahead and do is let's kind of go back and take a look at that function. Its highest degree is a 2. And notice here that it technically, because we don't see it, it has a lead coefficient of positive 1. So because it is an even degree, we know that the end behavior, and because our lead coefficient is positive, our end behavior is going to go up, up. And again, if we look at the multiplicity of our x-intercepts, we want to note that they each have a multiplicity of 1. So that means that when I'm drawing this, I'm going to cut through the x-intercept, and then I will cut through the second x-intercept. And it shouldn't be surprising that we basically did a rough sketch of a parabola. We want to know when our domain is greater than or equal to 0. So again, I note that, hey, my y values are above 0 or equal to 0 at this x-intercept. And then here again, we're equal to 0, and then we're above the x-axis where all the positive y values are. So my domain, go ahead and write it over here, is going to go from negative infinity up to 1. Because again, remember, your domain is referring to your x values. And then we're going to union that with, and actually I made a mistake, so hopefully you all caught that. I want to make sure that I'm including the value that would give me an output of 0. So I need to use a solid bracket here. And I also want to include that 4, so I'm going to use a solid bracket with the 4, and it's going to go to positive infinity. Here is my domain. I hope this explanation was clear. If you do have any questions, feel free to post them.